Hi there, welcome to this tutorial. I'm going to go through PySpark RDD and DataFrame programming for structured data analysis. So guys, we have two data structure in PySpark, but still this is a big question that when to use RDD and when to use DataFrame. All right, so as you may know, whenever you use RDD, we have to consider data row by row. And whenever you consider data frame, it means we have to consider data column by column. All right. So, but there are some trade-off between RDD and data frame in terms of performance, measurement, and complexity. So, but in this case, we want to go through data analysis, which is on structured data, and the main focus will be on RDD programming. But at the same time, I want to show you why we prefer data frame on top of RDD for structured data analysis. And of course, we will go through a few case study scenarios to see when to use RDD and when RDD is going to outperform data frame. So please follow me. All right, I want to take you into this tutorial and I want to basically resolve this big question: when to use RDD, when to use DataFrame. So first of all, on Google Colab, we need to install, PySpark. So it's going to install the latest release for us. So now we have to go through this link and download this KDDCOP99. This is the dataset that we usually use it for intrusion detection purposes. So regardless of what's going on with this data, I'm assuming you have zero knowledge of this data, and we want to take it over here and see how we're able to work around with this data. So you can get this data directly from this, URL. All right, and you can see that this is a zip file. It means in Spark, we can read, a zip file. So this is still, how we are able to request data. So you can run it. So if you face, guys, this error, HTTP error, all right, it means there are many requests, all right, out of this URL. It's better, to go through this link or might be through this link and download it manually and then drag and drop here. All right, it can resolve the problem. And if you're coming from one of my courses, all right, you can download it manually from Moodle site. All right, so if I refresh this, or you can see that this KDD copy is coming over here. So one reason that is a zip file, because we can reduce the size of data. All right, so let's see how we can go ahead. So first of all, we need to load data in RDD and DataFrame. It means that we need a Spark context to import data in RDD, and we need a Spark session to import data in DataFrame. So there are a few kind of syntax to initialize Spark, like for first one, Spark configuration. We can have app name. We can provide Spark master, means the local machine with as many as core available. Guys, you can refer to my previous video about how to initialize Spark from scratch, right? If you have zero knowledge, you can go through that video and go through initializing Spark from zero. So these are configuration. We can take it for RDD, and this is, we can take it for DataFrame. We can run it. So there is something wrong. I need to also Spark configuration. All right, and there we go. Right, this is what basically we need. So it's going to initialize Spark context for us and Spark for data frame. All right, first of all, we need to read data in RDD. So SC Spark context text file, guys, you can see that we can read this zip file, this GZ file, and we said, okay, let's partition it into 8 partitions. All right, and we can take 2, means please provide 2 records for us to see what's going on. So also we can convert this RDD to data frame. So guys, these are the schema. All right, these are the attributes and that have been collected here as the features. You can take them. All right. So then we can go through this RDD that we have it here, right? You can see that this is first record. 0 means duration of connection. So TCP is the protocol type. HTTP is the service. SF is the flag. So this one is a source byte. This one is a destination byte, and many more information. All right, till the last one, which is label. All right, which is label, because as I mentioned, we use this data for anomaly detection, for intrusion detection purposes. So we can flag a record as a normal traffic or attack traffic. So what we want to do, we have to go through this data because I want to convert RDD to data frame. All right, is the easiest way to do so. So we need to go through this, split it. All right, how to split? We have to use map. After splitting, we would say that please create a data frame based on the split RDD, and we can get this data frame. So again, guys, if you're a beginner for Spark RDD programming, if you're not familiar with map and transformation function in RDD, please refer to my previous video about Spark RDD programming. So perfect, guys, you can see that now we have this data into the tabular format. This one is into the row format, which is without a schema. And here we have a schema, right? Like duration, protocol type, and so on. So let's go through a bunch of tasks to get familiar with RDD programming, basically, and compare it with data frame, all right, to see how to go ahead and how we can sort out these typical data analysis on structured data. So the first task we need to consider here is count the number of records. So count is going to be, so let me close this one. So, and let me zoom in. Count is going to be a part of action operator. All right, I want to say that RDD record counts, for instance, something like this. I would say that data RDD.count. Okay, let's see how many data and how many record we have. So I wish to use, this time because I want to measure the time complexity. Why? Because I want to use same stuff. All right, this is with RDD, insert new code, and also I want to consider it with data frame. All right, in data frame, let's say data frame record count. All right. So you need to say data df.count. All right, let's see what are the outputs. So I'm going to run this and I'm going to run this. So let's see what's going on here and what we can get out of it. So RDD record, it says, all right, there are more than 4 million records. All right, and we are having here the time measurement. All right, CPU time and system time, total, and wall time. So here, guys, this wall time is going to be the actual time taken to execute the code. All right, guys, it means it's spent, all the time spent by the code, including waiting for input-output operation, other external internal factors, CPU time, the time taken to read data from hard disk or memory, and so on. This is all, the criteria that we can decide about. How long does it take? This syntax, and CPU times is basically just because of your CPU time, and this user here. It means that the amount of CPU time spent executing user code outside the kernel. All right, because guys, these are two belonging to CPU time, and sys time is the amount of CPU time spent executing code inside the kernel. All right, so and total is going to be 71 milliseconds for CPU time, but guys, as I mentioned, wall time, we consider it. All right, it's going to be the actual time taken to execute the code. So what we notice, guys, still same result, right? Count is same, but the big difference, guys, is in the timing. 11 seconds for RDD, 1 minute, about 1 minute. So guys, on these Jupyter Notebook on this Google Colab, we have 2 available cores. All right, the result comes from 2 cores. All right, and on my machine I have about 12 gig, free, but 1.7 is going for the system running, and about 11 gig is available here. All right, I'm going to spend all 11 gig for processing plus 2 cores. All right, these are the configurations. So, but why it's big deal, right? It's a big deal that RDD provide, this time 11.5 point second, but here we have 1 minute. Guys, RDD is a low-level distributed data structure. All right, it means that there is no schema. You can directly get in touch with data without any, additional layer of computation. All right, but DataFrame is a higher level abstraction built on top of RDD. All right, so guys, DataFrame in Spark introduce a logical optimization layer. We call it Catalyst. All right, so if I want to take you guys into this discussion, we have, let's say RDD. All right, RDD, it's going to be low level. All right, low level data structure. All right, that we can get, more manual control on data because there is no schema. All right, you can directly get in touch with data, but DataFrame is gonna be the higher level. All right, it's gonna be higher level abstraction. All right, on top of this RDD that provide guys a schema-based approach. A schema-based means we have column labels. All right, so DataFrame, this one, DataFrame introduce a logical optimization. We call it Catalyst. All right, we call it Catalyst. So this Catalyst, guys, optimize queries based on DataFrame scheme. All right, and apply various optimization like predicate, push down, guys. These are optimization techniques, and like column pruning. All right, and last one is gonna be code generation. All right, code generation. So guys, these are really great, right? We can optimize. All right, the queries using DataFrame, but guys, it's going to add additional headache. Additional headache here means that it's going to introduce, like additional overhead compared to RDD. So also for this, count here, I mean, we need to usually attributes like data representation, processing modeling, and caching. They are very important for processing at this stage. All right. So at this stage, RDD, since it's lower level control, it takes, caching for processing. That's the reason this count in RDD is faster than this count in DataFrame. All right, because RDD is a low level distributed data structure. So, but guys, this is always the trade-off between flexibility and performance, right? While you want to go ahead with RDD or DataFrame. So how we can sort out this problem to speed up, DataFrame? We can cache, right? We can cache also DataFrame. It means that we need to, do one thing. So first of all, make sure to from PySpark import, storage. You can see that storage level. All right, if I'm not wrong. So, oh, sorry, this is from, right? From PySpark import storage level. All right, let me use a new code cell. So run it. And then here, let me add also this time. All right, this time to measure it. So I want to say that data df dot persist. persist. So guys, when you say persist, it means I want to consider caching. So with persist, we have different level of, caching. You have to call this a storage level, this one. All right. So, and then press dot, and guys, different type of caching, disk only, memory and disk, and few more that I'm going to go ahead with this memory and disk. So memory and disk means that please, all right, please consider these data to be cached inside memory and disk. It means that if we have well enough space in memory, please, store it in memory. If you have no enough memory, please take a rest in the disk. All right, and then the data is going to be transferring between memory and disk. All right, so still we can, we can get advantage of memory, guys. This configuration is very related to your hardware configuration. If you have well enough storages in memory, and if your data is not too big, why not to entirely add data in memory? Just say that memory. All right, and then you can take advantage of cache. But guys, cache, it's not fully controllable by Spark, because cache is like a children for operating system. An operating system decides to how to cache data. All right, so it means that whether data can be lost, guys, from cache due to other application using cache. Let's say this is a machine, we are working with it, we have a Spark running on this machine, but at the same time, we are having some other applications that they are running at the same time, and also they use cache, right? So using cache depends on the caching mechanism, right, being used and the resources, guys, available on the system. So generally, when you use cache data in PySpark, it's stored in the memory, all right, and where the Spark is running. If other application on the same system using the same resources, guys, it's possible that there might not be enough memory, and then PySpark application cannot get all data stored in cache. All right, what's going to happen? That's the reason we say, okay, take into consideration also disk and transfer data between memory and disk. If you have well enough space, please let them stay in the memory. Otherwise, get them into the disk. And in this case, if you have no well enough space in cache, data may be evicted from memory, all right, or spill to disk. It means transfer from memory to disk. Guys, this is like additional overhead, right? Because we have to move data between memory and disk. But guys, for performance, to speed up and to boost performance, we basically need it. All right. So here, I want to say that please consider this one, guys. Whenever you say this at this stage, it means that this one doesn't mean, guys, trigger the actual persistent on the RDD or data frame, but in this case, it's data frame. It simply marks this data for persistence, for caching. All right. So whenever it's going to be executed, when data, let's say when an action, right, action operator like collect, count, take, and few more. Once an action is called, all right, then this persistence gonna be get executed. That's the reason the persist and all transformation operators in Spark, they are lazy. All right, we call them lazy evaluators. So let me also explain what does it mean, laziness. Okay, before moving forward, just let me go through this. This consideration, guys. In Spark RDD, we were able to say how many partitions we can have it. All right, but in DataFrame, because of optimization, structure, there is no way to say how many partition. But here you can repartition it. All right, you can say, all right, DataFrame, please get repartition. All right, repartition. Let's take the same partition we did for RDD, and then here I want to say that. So when you call this action, guys, now this is the action. All right. Once you have action.count, and then yes, this data will be stay on, memory and transfer between memory and this. If you have enough memory, it's going to stay on memory. Otherwise, it's going to do transfer between memory and let's say disk. So we can run it. All right. So I want to add another code. Why? Because if you run this one for first time, data will be cached. All right. Whenever you run count, data will be cached. So next time, if you run it, then the time gets better. All right. So we have to spend this persisting. All right. To speed up processing. So let's run this and then let's run this. Okay. So now let's move forward with this, whiteboard, because I want to talk about this laziness. So I'm trying to find my pen. All right. So guys, as I mentioned, transformation. All right, transformation is lazy. All right, because why we call it lazy? Because this laziness help for efficiency. All right, efficiency. It helps for optimization. All right. It helps for flexibility. All right, it helps for pipelining. Okay, pipelining. So guys, because big data processing and analytics gonna to bring all resources into the processing. All right, like make CPU, memory, bandwidth, cache, everything, make them engage with your processing, and making this transformation be lazy is very helpful to make sure if end user, right, end user is happy with the actual processing using transformation like map, like filter, and so on. All right, if end user is happy to do so, then using action allows to go through this huge data processing. So but there are lots of benefits like efficiency. So guys, laziness allows for optimizing the execution of transformation. So let's say that when a transformation is called on RDD, it doesn't immediately perform the computation. So what does it do? Instead, it builds a lineage graph. All right, we call it lineage graph. All right, or we call it, DAG, for instance. All right, direct cyclic graph. So this is a logical plan of transformation. Let's say you want to have lots of transformation back to back. Once do mapping, then flat map, then filter, then reduce by key, then group by key. Then again, you want to have map. So you can have a lineage graph, and it's helpful for fault tolerance purposes. All right. So then for helpful for optimization. It means that Spark can perform pipelining where multiple transformations are combined into a single operation. Guys, for what reason? To reduce the amount of data movement and improve performance. Okay, it's very visible, right? Very, it really makes sense. All right. Flexibility. Flexibility means we can, I mean, before going through, processing, this provides flexibility in composing complex workflows and allows for dynamic modification, guys, after transformation based on changing requirement and based on, the hardware that we have on board. All right. And also for pipelining, which is relevant basically, guys, for fault tolerance purposes. So Spark can keep track of lineage graph and reconstruct, all right, if there is any loss. All right, in terms of any failure, let's say you have 10 transformation, you want to do back to back, 2 mapping, 1 filtering, then reduce by key, then other flat map and so on. If there is any failure in one of these transformation, these pipelining and these fault tolerance can be helpful, right, to reconstruct this lineage graph or DAG, all right, to make sure where we lost and where to start, all right, and where we reconstruct. This is, the idea of how we call and why we call, uh, basically transformation is lazy. So let's get back here. What we can see here, guys, we spent 2 minutes to do this persistent and then repartitioning and take count, okay, all together. So guys, once you do for once, from now on, whenever you use action, can see that took 4 seconds. Just take into consideration this 1 minute. What we did, we just went through this caching, and of course repartitioning helpful to provide parallel processing. Why not to get this idea also for RDD? Let's speed up RDD. So how to speed up RDD? I would say that data RDD, all right, that persist. I want to take the same stuff, all right, I want to use same stuff. I will collect this, all right, and paste this one here. So guys, if you run this, as I mentioned, it's not gonna to get it into execution until you have an action. All right, if you have an action, it's going to you know execute it. So why not to do it? All right, and you can consider it. Okay, so if you run it, so data will go for caching. Guys, please be careful. If your data is huge, caching is not the right choice. Okay, sorry, this is I mean, this is not IT. I have to remove it. I have to stop it and run it again. So if your data is very huge, right, caching is not the right choice. It's better to cache the transformation. It means do mapping, all right, do mapping, and then persist it, cache it, all right, the result of transformation, all right. But or you can take this combination. Even if your data is very huge, why not to take this combination, memory and disk, all right, and transfer data between memory and disk. I know it's going to be add additional overhead because spilling is there, means moving data, but at least we can get better time complexity and the execution time. Okay, let's move forward and let's see how we can do. So guys, now for data RDD and DataFrame, they are now available on the persistent status, all right, using memory and disk. Perfect. Let's see from now on what will be happen. Filter the records including the protocol type TCP. So as usual, I want to use time to measure the time complexity. So filter, all right, filter the record including the protocol type TCP. So guys, if you want to work with RDD, as I mentioned, we have to consider RDD row by row. So we have to go back here. Where is TCP? TCP is, guys, is index 0, index 1. It means we have to split this data and then take index 1, okay, and then you can take it off. Okay, so how we can do so? You can come back here, task 2, and here I want to say that. And then we need to also, because it says filter, all right, so we need to say like filtered RDD, okay, please data RDD dot filter lambda. Guys, I'm using anonymous functioning. Again, if you're new in a Spark RDD, please refer to my previous video. which is going to be helpful to get in touch and grab the main point of transformation using filter, map, and many more. So lambda, I want to get input, right? So then split it basically for me, all right? Split it based on comma, all right? Get the second index, because second index was TCP. And then those ones that TCP ordered, because we have three type of protocols, TCP, UDP, and ICMP. So then you have to count it, all right? So filtered, let's say count, all right? Filter count. It's gonna be this filter RDD. So guys, here I need to say count, all right? So if you run only this one, I mentioned transformation is lazy because of those, criteria I mentioned. All right, it's not gonna to get executed. It's gonna to prepare something for us at the backend. Those, those elements that we discuss here. All right, they're gonna to provide this stuff for us at the backend. And whenever we use action like count, it's gonna to it's going to get into the execution mode. So I want to say print. Please print number of records with TCP protocol. All right. I wish to save filter count. Okay. So we can say, okay, let's run it. If you run it with RDD, guys, data is is transferring between memory and hard disk to speed up processing. So filtering is going on, and then count. So let's see how it's gonna to take it over. So the second one is time. So I'm going to use with RDD. So it says there are this amount of records, including TCP protocol. How long took? 17 seconds. All right, 17 seconds. So I mean, if you rerun it, let me rerun it. Okay, it was firstly 17. If you rerun it, means that you need this, a transformation action. They're gonna be cache, all right, because it's gonna to take advantage of caching, and let's see how it's going to improve it. So somehow same, all right, because we had caching and we could, because of this one caching here, we took advantage of caching here. All right, it means this is the best timing, all right, based on the hardware available on this Google Colab. Let's go ahead with DataFrame. Let's see how we can do it with DataFrame. So I want to say that filtered DataFrame. All right. So guys, for DataFrame, you can use SQL API or DataFrame API. So I want to say that data df dot filter. I'm using API. So DataFrame dot. So you need to go through DataFrame and find where is this TCP. TCP is here. What is the schema protocol type? So I want to use dot notation. You can use bracket notation. All right, means that you can here use bracket notation. Okay, but let me to take this dot notation protocol type. Then I want to say that contain. All right, contain TCP. All right, so with filtered counts, all right. With DataFrame, it seems it's much easier, right? Then that count, okay. And then why not to copy this one? And of course, paste it here for this one. So if I run this, guys, for a second. So guys, if you run the same stuff on Google Colab, you might get 2 seconds, 3 seconds. Okay, guys, it depends on the availability of hardwares. All right, you're running on Google Colab. If I run it again, it was 4.8, right? Guys, gets better because of caching. All right, so if I rerun it, it seems this 2.2 is gonna be, the best timing, because of, after caching data. So guys, still DataFrame provides better solution. All right, Why? Because of this discussion that we had we had here because of this catalyst, right? Having predicate push down, column pruning, and code generation. So I want to add few more stuff also in DataFrame. All right, let me add it more. So in DataFrame, let me add it here. So the reason of DataFrame is faster than RDD is one was this catalyst optimization that I've been discussed. All right. So I mean DataFrame use catalyst, which is an optimized query planner, guys, to analyze and optimize the logical plan before execution. All right. So how using rule-based optimization, predicate push down, constant folding, and these are really helpful, to take DataFrame into the optimization level that RDD basically is suffering to do so. There is no optimization. So the second thing in DataFrame which is running, we call, tungsten execution engine. All right. So DataFrames use this tungsten execution engine, which includes, guys, code generation techniques. Tungsten can generate, guys, byte code. Okay, let me write it, byte code. For specific operations, okay, because this lead to more efficient execution, guys, compared to interpreted execution that we have it in RDD. All right. So the third one is higher level abstraction. All right, DataFrame provide higher level abstraction. So and this is also helpful to, to speed up DataFrame. Let's say higher level abstraction. All right, and last one, which is very important in DataFrame, we call optimized storage format. So what does it mean, guys? When reading data in DataFrame, Spark can leverage optimized storage format like Parquet files and ORC. All right, so let me say here Parquet file, which is specifically for this, view size data, and ORC, data format. All right, that because they provide compression. All right, they provide compression and of course predicate push down capabilities. So two things I'll have to mention, these two guys together, they provide better compression of data. All right, and then of course to provide predicate push down capabilities. Perfect. That's the reason DataFrame is faster than RDD. All right. So, but we will consider a few more case studies that RDD, provides better solution as compared to DataFrame. But generally speaking, DataFrame is much better than RDD because of time complexity. Okay, let's move forward. Task 3. So time to find a distinct type of services. So in RDD, you have to go through data and see where is it. Services is here, right? This one, this index 0, index 1, index 2, right? Is in index 2. So it means that we have to split again. All right, and then find a distinct version of it. So come back here again. Let's say service types RDD. So you have to say data RDD, please firstly map. So you can take firstly map and then filter. All right, or but here we don't need filter. We just need to get the distinct version. Okay, let's ignore filtering. let's go through mapping lambda x. For x splitted, x here, guys, is going to be a line. Let me name it line. So, and then it's going to get the idea of we want to consider each line because RDD reads data line by line. So line dot split. All right, again, based on this comma. And which room? Room index 2 means index 0, 1 to third room. All right, and then distinct service using RDD is going to be this service type RDD. All right, guys. Dot distinct. All right, then collect. Okay, then collect to see the result and print. So distinct service type is gonna be this one, guys. As you know that collect is very important. If you know that the output is a small size, not gigabytes, collect, you can use collect. Otherwise, it's better to use take. So let me run it to see what is the output and how does it take. If you want to do it with DataFrame, okay, you can insert new code. Let's say this, I want to just name it. Let's take data df. Then select what you want to select. I'm going to use, this DataFrame API. I want to select service, which is the column. So guys, you can come over here. We are talking about this one, right? This column, service, third one. All right. So, and then I would say dot distinct, okay, and then dot show. Guys, easy, right? Truncate, also you can get truncate to see the output fully, the full output, and that's it, right? And you can also say time. All right, so why not to take, the same, approach, and then here distinct is gonna be DataFrame. All right, so I'm going to take you from here and paste it here to do like this. And if you run this, so 22 seconds for RDD. Why? Because as I said, there is no optimization approach. It's low level data structure. All right, but for this one, we are taking 8 seconds because there are optimizations. All right, what type of optimization? Guys, these 4 type of optimizations and techniques to provide this service for us. But guys, by default, it's going to, print out 20 records. How to stop this, restriction? You have to say how many n means how many records you want to visualize. I will say that, okay, data df, count it, okay, based on the number of records available. Might be, you can say like 100, right? It's going to print out 100 records for us. But let's take, count, because we had this count cached, right? Means that whenever you use it, we can use caching data. All right, so you can see that everything is here in one table and 10 seconds. Still better than RDD, right? 10 seconds, here is 22 seconds. So this one, if you rerun it, it was 22 seconds. All right. So guys, at any time that you execute the cell, it depends on the resources, the available resources, like the CPU and memory. Sometimes, like at this time that I'm running, maybe the CPU and core, those 2 cores and memory might be, they are busy, right, with other tasks. 1 second better, all right, but still this is the optimized timing because of caching we did at the beginning. So all right, let's move forward, right? We want to calculate this average duration of connection and do a few more tasks, all right, to see, okay, at the end, how to go ahead, how to select data frame and RDD, and how to answer to a question related to structured data using RDD and data frame. So again, time, calculate the average duration of connection. So duration of connection, guys, is the first input, right? In RDD, is here, right? Duration is the first column, all right? And in RDD is going to be first item. Again, we have to split and take over the first one. So here I have to say that, so duration RDD, all right, data RDD dot map lambda, let's say line, okay, and then line of the split, okay, based on comma. So guys, split is always required for RDD, okay, and then index 0. Make sure to convert it to integer, all right, because otherwise you're going to take it string format. What I want to do, and then I'm going to calculate the average, because the task is asking average duration is going to be this duration RDD. So guys, in RDD we have this average, okay? You can calculate the average, and let's print it. What to print? I want to say that average duration of connections, all right? So then this, you know, average duration. We can run, and then, you know, how to do it with, you know, DataFrame. In DataFrame, so for averaging, what we can do, we can import the method from PySpark, all right, .SQL functions, all right, import average, okay? Guys, please make sure to take functions from PySpark library. If you import from Python library, you get error, right? Because of the size of data, and Python is not capable to run your code in parallel, right? Just a Spark can do that. So 45 seconds, guys, again, if you run it, you might get the difference, okay, in terms of your CPU and memory availabilities. So what is the duration? 48.34. Okay, the average of duration. Let's do it with DataFrame. With DataFrame, I want to say that average of duration. Okay. Here I want to say data df. Let's group data. Okay, group by. Okay, and for grouping by, you know that we can use aggregation. Aggregate the result based on the average of duration. Why not to say alias? Okay, change alias to change the column name to average. Maybe this one, right? Average duration. All right, that's it. And then you can say .show. If you run, we expect to get better timing. All right. Great. So same output. All right, a bit difference. Okay, a bit difference. Because you know the maybe from here is very common. All right. So how many decimal points? About 8 or 9. Correct. Just a few decimal points. That's not really big deal. And this is because of, you know, how RDD and DataFrame take them over. How long? 7 seconds. Guys, that's perfect. All right, that's super. So task 5, find the maximum number of source bytes in a connection. So source byte, again, you need to find where is it. Okay, source byte. Let's come over here. So source byte is here. Means index 0, 1, 2, 3, 4. It means if you want to work with RDD, you need to get, you know, 0, 1, 2, 3, 4, right? This one, 215. So we need to, again, we need to split and take it off. All right. So it means that time. All right. So source bytes, RDD, right? Data, RDD dot map, as usual, map. Okay. So then lambda, let's say line or X. Let's see how you are convenient with this line that is split. So again, based on comma, which room? Room number 4, right? It means index 0, 1, 2, 3, 4 means room number 5. So let me double check if I'm not wrong, right? 0, 1, 2, 3, 4, right? It's gonna be 4 means exactly, room number 5. So here we are collecting, and then, okay, let's say to collect, get the max. So let's say max source, bytes, gonna be source this one. All right, dot max. And here we go. Let's say print maximum source bytes in a connection, something like this. All right, and then max source, bytes. Okay, let's run, and let's do same thing with data frame. Okay, with data frame timing. All right, so with data frame. So for data frame, first of all, this max, you need to get it by a function like this from here. All right, so here I need to get max. All right, so max source bytes. I want to use data frame. All right, so I need to work with the column. All right, which column? I have to say that with column. All right, so first of all, we need to convert it to integer. I'm using with column to say that still keep it as source bytes. All right, which column? Column source bytes. So guys, make sure to also import column. Okay, import column to be able to use column. So, and then dot cast integer. Okay, guys, this is what we can do. Let me go to the next line. So we are now casting. But guys, I'm taking this one wrongly because we have to firstly cast it. Okay, and then then aggregate it. Aggregate based on the maximum of the source bytes. All right, why not to get also alias to change the name of the column? So why not to get the same stuff from here? All right, and why not to copy exactly the same thing from here and paste it here? Okay, something is wrong. Let me check. So data with our source byte. All right, and then column source byte dot cast to integer, then dot aggregate based on the maximum of source byte dot alias maximum. So let's, guys, I think we need to double check also this one. Data RDD dot map lambda. We want to split it. All right, guys, I'm missing because here should be integer. All right, otherwise it's not providing the right output. Okay, let me run again. All right, in the meantime, let's double check this one. So data, okay, this is the maximum source byte. Okay, how many minutes? 21 seconds. So let's double check, guys, this one. PySpark SQL function, import max and column. So data df with column. So name it source bytes. This column, source bytes, cast it to integer, please. All right, and then dot aggregate the maximum. The maximum of source byte dot alias and this one. All right, so okay, I'm doing something wrong. This one should be dot show, or maybe just say dot show. This is what I'm doing wrong here, okay? And show me. All right, great, guys. The same output, right? The same output. So, but 21 second, here is 7 second, guys. Still data frame is much better. Task 6, calculate the total number of connections that are labeled as normal. So it means that, again, for RDD, let's say normal connection. All right, RDD, we need to say data RDD dot filter, guys, and then lambda line. All right, so again, line dot split. Okay, based on this comma, and now we need last column. I mean last data, last item. I need this one. How to mention this one, guys? You can count from beginning, indexing 0, 1, 2, 3. You can count them, or you can use negative indexing, right? -1 means start from end. -1 means normal, means last item. So here, I wish to say, please get me, index -1. All right. I wish to be normal dot, because that one is appearing in data. So then you can count it, right? Normal connections count. Let's do like this, and this the normal connection RDD dot count. Okay, that's it. And then we can print it. Print, let's say, total number of normal connection. All right, and then it's gonna be this one. All right, so why not to use time to measure it? So you can do it with DataFrame. So with DataFrame, it's gonna be much easier, right? With DataFrame, I want to say that total normal connections, for instance, and then this DataFrame dot filter. So which column? Guys, we imported this column here, right? So column, which column? I want to say that column label. All right, I wish to be, normal. So, but please make sure that normal is with dots or without dots point. So, all right, with dot is, normal dots. So, equal to normal dots. All right, and then count it, right? So, and then show the result. Means that here you can take the same stuff. Okay, and then here I can say connection and run it. So 20 seconds, and this is the total number of connections. So the same output, but 2 seconds, guys. Still, DataFrame provides better, outcomes. So task 7, group the record by type, normal or sub attacks, and count the number of connections. It means that we have to collect last column, right? And see how many traffics are normal, how many traffics are attack. So in DataFrame, it's going to be very easy, right? If I take, DataFrame, we can say connection by, protocol. Let's say type sorted, for instance. Okay, I want to say that df dot, data on the line df dot. So let's group by, because the task is group by. Okay, group by based on label. Okay, so what is the aggregator? Count is the aggregator. And why not to order, right? Order by. Where are you? Order by? Order by based on this count. Okay, and ascending, false, because I want to put in descending order. And what I want to do, I want to show this one. I want to say that please dot show. Why not to use this truncate? All right, false, and this n, let's say 100 record. All right, or maybe again you have to say data df.count. Okay, if you run this, so guys, perfect. Smurf, this number of records, these are guys attack types. All right, normal, traffic, IP sweep, these are all guys. The rest except normal, let's say the rest of labels, they are attack types, but just normal is a normal traffic. All right, we could count them out. How many time? I mean, how long does it take? 10 seconds. All right. So, but how we can do these is easy stuff. All right. With RDD. So with RDD, it's a bit challenging. So please follow me here, because in RDD we have to count. Okay. So how many partitions we had, guys? We had 8 partitions. Okay, let me bring 4 partition here. We can discuss, what's going on. We have data like 0, few numbers, and last column is like normal. All right, we have few and then last is normal. We have few and last value is, let's take, like smurf. Okay, this one. Okay, it's gonna be smurf. All right, then here we have few records starting from, the duration, and then let's say again, smurf is there. Run it, and then we have, normal. And few more. Here, guys, let's say here we have just normal. I mean, few data normal, few data normal, few data normal. And last one, we have only smurf. Okay, guys, let me go through this one, or maybe we can add one more. It's gonna be this land on nm. Nmap, okay, nmap, and few more. So how we can count them, right? How we can group by, guys? The solution in RDD is like this. You need to take them out like normal, all right, and add number 1 in front of it, guys, because we want to count them. All right, so you need to get smurf out and put number 1 in front of it. For this one also, smurf, number 1 in front of it, normal, right, number 1 in front of it. So normal, number 1 in front of it. Maybe we have one more, right? Normal, 1 in front of it. If you have one more, you can repeat this. And of course, we can repeat, same stuff here, right? Smurf, number 1 in front of it, and nmap, number 1 in front of it. Guys, why we need it? Because we have to aggregate them now. So how to aggregate? You have to come through the same keys. These are the same keys. It's gonna be normal, normal 2. All right, so these are gonna happen in the same partition, normal 2. All right, and then these gonna happen normal, 4. All right, and so on, right? It's gonna happen same for smurf, means that smurf here and the smurf here, right? It's gonna be smurf 2. All right, and here we have one more smurf here. It's gonna be smurf, 3. All right, this is how we can take RDD working. So first of all, we have to make this one. All right, we have to create this one. How to create that one? Again, mapping, right? Let's say attack. Let me call it attack RDD. All right, I want to say that data RDD.map lambda get each line. All right, and line dot split. So based on this comma, get last value and put number 1 in front of it, and make sure to add it into a tuple, right? Into a tuple. Okay, so it's done, right? We could do that. We could do this step. So how to do this step, guys? This is exactly reduce stage. Guys, again, please refer to my previous video if you are not familiar with reduce. So reduce means that I want to aggregate. So in this case, guys, aggregation is based on the keys, means to aggregate normals together, aggregate smurf together. It means that here let me say connection per attack RDD. I want to say that this attack RDD dot reduce by key, right? Reduce by key. So get lambda, let's say x and y, and then x plus y. Easy aggregation. That's it. All right. So then you can count it. Okay. You would say that this one dot counts. All right. So why not to name it connection per attack list, for instance. Okay. So, and then let's print it out. If you run, we expect to get more time as compared to this data frame, guys. With data frame, you can see that we can do it easily because here you can use group by to do so. But here for group by, we have to use mapping firstly. All right, and then for counting, we need to add this number 1 and then collect them. All right, so all right, sorry, not count. We have to say collect. Okay, we have to say collect. All right, great. So this is the output. So you can see that is into the list format, 21 second. Guys, if you are not happy with this visualization, you can convert it to a tabular format. How to convert it to tabular format? Let me close this one. Maybe I can open another one. So if I say this one, let me try it. If I can use to frame, I'm not sure if it works to frame. No, because it's relevant to data frame. Oh, okay. This is a list, right? This is a list, not a data frame. So also is here, it says list object has no attribute to frame. So what can I do? I can import pandas as PD. Okay. And then here I want to say that df is PD. I want to create a data frame. All right. Data frame. Please get this one. All right. And add these column labels, columns. Okay. So first one service, second one is count. Okay. And that's it. And also you can sort it, right? Then sort values. Guys, this is pandas syntax based on count column. Ascending false means put it into the descending order. So why not to get it from here and put it here? All right, and take everything together. And why not to get this import here? And that's it, right? Let's run it. So this is what we have here for data frame. And also you can do it for RDD. All right, guys, perfect. In the tabular order, Smurf, count, Neptune, count, and exactly the same result, guys, for this one. All right. So, but timing, right? 21 seconds. But for this one, it takes 10 seconds. Last task, calculate the number of connections for each attack type and protocol, guys. I'm making the task, get them, into the difficult order from easy task to difficult task to show you that how to go ahead for structured data analysis using RDD or DataFrame. So let me take this one firstly with DataFrame, because DataFrame is take this one easily. Connections, let's say by attack and protocol, right? This is what question is asking. So I want to say that data underline df. So firstly group by plus group by. So guys, here we have to group by based on 2 columns, label and protocol type. Okay, 2 columns. And then how to aggregate? Count. And why not to rename them, right? With column with column renamed, all right, into count. And I mean, I want to, because here count is a lowercase, I want to do it into the uppercase. Okay, that's the reason. Let's do it like this with uppercase count. All right, so why not to say that protocol dots. Let's also use order by. Okay, order it based on what? Based on label, and then also protocol type. Okay, and dot show. Let's use this trunc false. If you run, okay, guys, we forgot to add this time. Okay, I can stop. Okay, it's running. Let me run again with. Oh, sorry. Again, my mistake. Let me stop it. So remove IT, just time. So guys, perfect, right? Based on label back, and then this TCP, we have 2,203 TCP connection. All right, we have 3 TCP connection for this label and the rest 8 seconds. How to do it with RDD? Guys, with RDD, we have to take the same approach we did here for task 7. All right, it means that we have to get them out, add number 1 in front of each because we want to aggregate everything. All right. So it means that label protocol. All right. So count RDD. It's gonna be data RDD dot map. All right. So lambda. So for line. So please line. I need you to be like this. I need to say that line dot splits. So where is label? Firstly, let's do split. So firstly, it's this label is going to be index -1. Okay, so then I want to do another split, or maybe you can do a split for once. Okay, and then take it over here all together, or you can do it both together, right? Again, split and take index 1 means second column, which is protocol type. Okay, so get them together and add number 1 in front of it. Okay, guys, so why not to get one more parenthesis? That's it. Okay, this is what we need. So then we have to say connection by attack, let's say, and protocol RDD. All right, so I want to say that label protocol count. Dots again, guys, reduced by key. So guys, in this case, we have 2 keys, right? The keys is, but guys, the concept is still lambda x and y is gonna be x plus y. Okay, so here, but guys, the key is 2 keys, like backend TCP, right? 2 keys, because here key is 2 items. Okay, so then display. All right, result, or maybe you would say that this one dot collects. All right, why not to use this time, and here we go. All right, so 28 seconds, and the result we are collecting. So as we did for task 7, you can also convert it into the tabular format. You need to convert it to data frame. So guys, we went through 8 tasks one by one, from the easiest task to this, the difficult one. But we found out data frame is much easier and much faster than RDD. All right, so But here we need to have a conclusion, guys, on this case. So if you have structured data, all right, if you have structured data, I mean, structure means you have a schema. It's better to use DataFrame, all right, unless you have a complex transformation that's not possible to do with DataFrame. So for instance, let's say, suppose you have a large data set of customer transactions and you want to calculate the total revenue generated by each customer over a certain time period. All right, let's see. You may find these transactions difficult to write it with SQL. Maybe it's impossible to do so, right? It means for complex transformation, all right, we have to use RDD. Why? Because RDD is based on Python, guys. You can write Python easily and send it to the map, to the filter, and run, right? There is no any boundary, there is no any restriction for RDD. So there is another exception we call iterative algorithm. Even if you have iterative algorithm, still RDD is the best choice. So suppose you are implementing, guys, a iterative algorithm like gradient descent for training, for a machine learning purpose, guys. At each iteration, you need to update the model parameters based on the gradients computed for the guide training data. Iteration provide, you know, really nice, I mean, based on time complexity. RDD is the best choice. All right. So let's say that if you have data with, let's say, irregular structure, okay, structure. Again, RDD is the best choice. All right. So how? Suppose you have a data containing, guys, JSON records, like a nested structure of JSON records. RDD provide better, you know, solution. Why? Because on RDD you can use complex transformation, and of course there is no schema, right? You can avoid a schema also for JSON files or other type of data structures, like there is no pattern. So these type of data structure, it's gonna be this one. Is gonna be on a structure. All right, like log files and semi-structure like JSON file. All right, for these typical stuff, you can use RDD. And the last one, fine-grained control. You can also name it here. So fine-grained control. All right, again, RDD is best choice. Okay, so because, guys, we discussed, guys, at the first task, RDDs provide fine-grained control over data partitioning, caching, serialization. That's going to be, guys, optimize the performance automatically. We don't need a schema like DataFrame. Okay, so it means that if you require explicit control over these aspects, RDD can offer better performance, guys, compared to DataFrame. All right. So these are the things, guys, you need to consider. All right. And to decide how to use this RDD and DataFrame. So for a structured one, let's recap again. For structured data, DataFrame is always the best choice. I mean, we went through different tasks and you saw that DataFrame provide, you know, faster solution. But in these, you know, cases 1, 2, 3, and 4, you need to consider RDD. All right, for processing. I hope you enjoyed the session and see you guys.